Hi, Assalamualaikum and good day everyone. So for the second video untuk chapter 7, kita akan tengok 7.2 the chemical properties of haloalkane. Okay, so untuk reaction dalam haloalkane ni kita ada beberapa bahagian lah. So first part misalkan fokus on nucleophilic substitution reaction, and maksudnya kita akan ada penggantian dekat situ. Kita ganti dengan apa? Kita ganti dengan nucleophile. Alright. So the second one kita akan tengok later, which is elimination. Okay. And for your information, untuk elimination ni kita dah tengok hari tu dalam alkene. Okay. Reaction yang sama je, cumanya diulang semula sebab now kita tengok topik haloalkane. Okay. So, before we go further, kita kena tahu dulu haloalkane ni macam mana. So, for haloalkane, okay, it will undergo nucleophilic substitution. Why? Because kalau kamu tengok dia punya bond, okay, dekat sini, let's say you have, this is your alkyl group lah, alkyl group R, any alkyl group, and then X sini adalah your halogen. So, X adalah your halogen. So, X here is your halogen. And then, let's say this is your carbon. Okay. So, for this case, you can say that halogen, as you know, dia akan jadi side yang lebih more electronegative, maksudnya electron density akan bertumpu ke arah X. Okay, partially negative, maksudnya more electron in this area lah. So electron akan tertarik ke arah halogen. Okay, so this will make the CX bond. Okay, kalau kamu tengok dekat this part, okay, mesti zoomkan. Okay, so you can see here, the carbon-halogen bond in haloalkane is polar bond. Kenapa polar? You already learn kalau polar means ada satu side partially positive, satu side partially negative. Okay, you can see the differences. So in this case, dekat part halogen, this part, dekat part halogen, it will be more electron. So, dia akan jadi partially negative, more electronegative than carbon. So, the carbon side here, it will be more positive. Okay. So, this will make your carbon side ni akan jadi electrophilic side. Okay. Maksudnya, electron poor region. Okay, so bila dia region ataupun site tapak ni kurang elektron, means dia lebih mudah menerima untuk serangan daripada luar, which is nucleophile yang rich elektron lah. Okay, nucleophile, the species that has rich electron, okay, extra elektron, dia akan attack carbon. Okay, so carbon apa? Carbon yang directly attached to halogen. Okay, so nucleophile, electron rich species, dia akan attack carbon. So which carbon? Carbon that directly bonded to halogen. Okay, dekat sini. Mesti syarat dia wajib directly bonded to halogen. Okay. Dalam nucleophilic substitution, okay, nucleophile akan ganti halogen. Okay, so you can see here, ini kamu punya haloalkane. Okay, so nucleophile akan attack carbon. Okay, so ingat nucleophile kaya elektron, rich electron, dia akan attack carbon yang kurang elektron, poor electron. Okay, and your halogen here, halogen dekat sini dia akan leave. Okay, so maksudnya bond dekat sini akan putus. 2 elektron ni kita akan bagi kepada halogen. So halogen, we know that it is a good leaving group. Why? It is easy for it to leave a stable halide ion. So dia akan jadi X minus ion lah. So for example, Cl minus, Br minus, and so on lah. Okay, commonly kita jumpa Cl dengan Br minus ion. Okay, so now you can see that nucleophile tadi yang attack this carbon digantikan tempat halogen just now. Okay, so there are few nucleophiles, type of nucleophile that you need to know. Ada 2 jenis nucleophile yang kamu kena tahu, strong nucleophile dengan weak nucleophile. Untuk main reaction of haloalkane, okay, kita dah pun belajar tadi that X will be leaving group and nucleophile akan gantikanlah position your halogen. Okay, so there are 2 type of nucleophilic substitution. Ada 2 jenis, SN1, SN2. Untuk chapter 7 ni penting kamu tahu cara untuk classify haloalkane because this will determine dia akan undergo which substitution. Sama ada the first one is unimolecular nucleophilic substitution reaction ataupun nama pendek dia SN1, ataupun bimolecular nucleophilic substitution, we call it as SN2. Okay, now let's have a look at the reactivity for both SN1 dengan SN2 untuk haloalkane. So here are some example of haloalkane. You have iodoalkane, bromoalkane, chloroalkane, and fluoroalkane with fluorine. And you can see that these are arranged according to the reactivity. Okay, so this side adalah the most reactive. Okay, why kita cakap iodoalkane is the most reactive compared to others? Okay, this is because the strength of the carbon and halogen bond, carbon dengan halogen bond, okay, it increases semakin kuat from iodine to fluorine. So bond between carbon dengan iodine yang paling lemah lah, the weakest bonding between carbon dengan iodine compared to carbon dengan bromine, carbon dengan chlorine, and carbon dengan fluorine. Okay, so when it is the weakest bond, that means bond energy that we need to break the bond between carbon dengan halogen, which is in this case your iodine. Okay, it is the lowest compared to the others. Therefore, the weaker the bond, the easier to break. Therefore, iodoalkane is the most reactive compared to others. And normally dalam kamu punya reaction in your syllabus, kita hanya akan deal with bromoalkane and chloroalkane sahaja.